Welcome back to The Explainer, everyone. Today we're jumping right into a really fascinating exploration. We're going to look at the animal kingdom and try to untangle its mysterious and honestly deeply misunderstood relationship with melody and rhythm. We're asking one absolutely fundamental question. Do animals actually enjoy music? Let's get right into it.
To start things off, I want to anchor us to our own physical experience with this. Just imagine you're sitting in your room listening to your absolute favorite song. Maybe it's a super sad ballad, maybe it's blasting loud, or maybe it's just that one track you've replayed like 50 times for absolutely no logical reason. Think about what's actually happening in your body right then. When the beat drops or a really beautiful melody swells, your brain releases a huge hit of dopamine. You know, we humans treat music like it's our own personal superpower. We use it to celebrate, we use it to help us fall asleep, and yeah, we use it to survive heartbreak. Literally, no other sound affects us the way music does.
But then, imagine your dog casually wanders into the room. You're having this deeply profound emotional experience, but what's happening inside their head? Do they just hear random, annoying noise? Do they feel anything? Can an animal actually enjoy music the way that we do? Okay, let's dive into this.
Section 1. The Anomaly. Snowball the Cockatoo. So this right here is the inciting incident that totally shattered the illusion that rhythm is a uniquely human thing. Back in a 2009 study at the Neurosciences Institute in California, a researcher named Anirudh Patel studied a sulfur-crested cockatoo named Snowball. Now, look, the internet absolutely loves videos of animals dancing, right? But most of those are just coincidences or train tricks. Snowball was an entirely different story. He was capable of spontaneous beat synchronization. He wasn't just reacting randomly to a sound. When scientists changed the tempo of the music, speeding it up or slowing it down, Snowball actively adjusted his own movements to stay perfectly synchronized to the beat. I mean, this forces us to rethink everything. It raised the incredibly strange possibility that the foundations of music already existed in the animal kingdom long before humans ever evolved.
Section 2. Nature's Original Composers. Now, before we can even figure out if animals enjoy music, we kind of have to define what music actually is. Because a random sequence of sounds, that's not music. To be music, sound requires structure, patterns, timing, and expectation. And from a purely biological standpoint, music is actually incredibly unnatural. It relies entirely on your brain's ability to constantly predict what note is coming next. And when the music surprises you in just the right way, mapping perfectly to those expectations, boom, your brain triggers that sweet dopamine release. And this brilliantly illustrates why there's actually an entire scientific field dedicated to this exact phenomenon. It's called zoomusicology. That is the scientific study of music-like aspects of sound communication among non-human animals. The term was popularized by the French composer and researcher François-Bernard Mach back in 1983. Now, this definition is where things start becoming just a little bit uncomfortable for our human egos. Because think about it, if animals produce things that actively resemble music, then our favorite art form might not be as uniquely human as we really want to believe. Let's look at how this builds across an evolutionary timeline. Millions of years ago, way before the first human ever carved a basic instrument, whales and birds were already evolving these intricate songs. Fast forward to the 1780s, and we have this famous historical anecdote where Wolfgang Amadeus Mozart owned a pet starling in Vienna that reportedly mimicked parts of his actual compositions. I mean, imagine creating music so recognizable that a completely different species just starts copying it. Crazy, right? Then we hit 1983 with the popularization of zoomusicology, and finally 2009 when those breakthrough studies on Snowball the cockatoo and tamarins were published. This deep evolutionary history shows us that sound patterns are fundamentally built right into the Earth's DNA.
Let's take a closer look at birds, who are basically nature's absolute maestros. Just like human children learning language, some songbirds actually learn socially. They listen to the adults, they make mistakes, they improve over time, and they even develop regional accents. A 2014 study by David Rothenberg and his colleagues proved that bird songs contain repetition, variation, and phrasing. Those are the exact structures we humans associate with music. But here's the real kicker. Male birds frequently sing much more complex songs during mating season, not because it's necessary for survival, but just because females seem to prefer it. That means aesthetic beauty has actual, real evolutionary value. Oh, and we definitely can't forget the extreme mimics out in Australia. Lyrebirds can copy camera shutters, human speech, and even chainsaws with terrifying accuracy. It is a little bit alarming, but you got to admit, it's undeniably impressive. Moving on to Section 3, a matter of biology. So this brings us to the great misunderstanding of why our own pets usually completely ignore our favorite Spotify playlists. You might be playing a song that sounds emotionally devastating to you, but to a cat, it's just completely meaningless. Why is that? Well, because human music is meticulously designed for the human nervous system and our specific emotional spectrum. Animals just hear the world differently. Dogs, for example, hear much higher frequencies than we do. Elephants use ultra-low frequency vibrations that we can barely even detect. Whales communicate across enormous underwater distances. Human music simply doesn't align with the biological wiring of other species. We are quite literally broadcasting on the wrong frequency for them.
Section 4. Designing Animal Playlists. So what actually happens if we create custom, species-specific tracks? In 2009, psychologists Charles Snowden and cellist David Tye conducted a fascinating experiment with cotton-top tamarins at the University of Wisconsin-Madison. When they played regular human music, the tamarins showed little to absolutely no behavioral reaction. But then, the researchers created species-specific music using the distinct tempos and frequencies found naturally in tamarin vocalizations, and the animals reacted immediately. Calming tamarin tones induced visible relaxation, while threat-like, much faster tamarin tones caused extreme agitation.
So the crucial point here is animals may not dislike music. They may just dislike our music. Let that sink in for a second. It is a profound shift in perspective. They aren't ignoring the concept of melody at all. They're just ignoring our highly human-centric version of it. Consider the number 100. You've probably heard that old wives' tale that cows produce more milk when they're listening to music, right? Well, strangely enough, there is hard scientific evidence behind it. In a 2001 study at the University of Leicester, researchers found that playing slower music, specifically right around 100 beats per minute, appeared the most effective at reducing stress in dairy cows, which physically improved their milk production. It's not magic. Stress hormones negatively affect milk yield, and relaxed animals simply produce more. The music actually altered their physiology. Now, obviously, this doesn't mean cows are having deep emotional epiphanies to a 100 BPM track, but it absolutely proves that rhythm and sound profoundly alter biology.
Section 5. The Universal Rhythm. Let's tie this all together and connect these physiological reactions back to the evolution of the brain itself. How does a creature even learn to dance in the first place? Well, scientists call this three-step progression the vocal learning connection. Step 1. Brains evolve for complex vocal imitation. We see this in parrots, some songbirds, and of course humans. Step 2. Because the brain is building complex wiring to mimic sound, the neural machinery required for rhythm synchronization accidentally forms right alongside it. And Step 3. The ability to dance or move to a beat emerges organically from those newly formed communication pathways. Honestly, this is one of the absolute strangest and most fascinating ideas in neuroscience. The ability to enjoy a beat might just be an evolutionary accident, a byproduct of a brain that was originally just built to copy sounds. Which leaves us with one final, incredibly provocative thought. Are we asking the wrong question entirely? You see, asking do animals enjoy music assumes that music is a human invention that animals are merely experiencing. But look at this idea. What if music is older than animals? What if humans didn't invent music at all, but simply refined the universal rhythms that already existed in nature? Think about it. The heartbeat, the rhythm of footsteps, the cadence of falling rain, the crashing of ocean waves. Bird songs contained repetition and variation long before we carved our very first flute. Whales were singing complex symphonies before humans even discovered agriculture. The deeper we study this, the less separate humans appear from the rest of life. It turns out we're all just dancing to a rhythm that was here long before us. Thank you so much for joining me on this explainer. Keep learning, and I'll catch you in the next one.